Hello students, welcome back. Let's resume our discussion on the elementary derivative rules. Oh, by the way, I'm using the term differentiation rule. What do you mean by differentiation? To differentiate is to find out the derivative function. So differentiation is probably better terminology than derivative rules. Anyway, here we go. The derivative of constant is 0. Derivative of sum is sum of the derivative, and the coefficient you can multiply either before or after. The derivative formula for the power function, power comes out as coefficient and subtract 1 from the power. And the derivative rules for exponential and logarithmic function. Natural exponential functions stay the same. Natural logarithmic function becomes 1 over x. And let's use these in this kind of problem. Okay, how do you handle this? In this kind of problem, you should not be taking the derivative and the derivative separately and multiply. You see, this rule applies for coefficient when a is constant, free of variable. But here 1 plus t has t in there, so you can't really do it. So the derivative is not equal to the derivative of the first function times the derivative of the second function. You see, if you take the derivative of 1 plus t, you're gonna get derivative of 1 is 0, and then next, and then this one, like that. But this is not true, this is false, because this is a t expression, not a coefficient, so you cannot use the coefficient rule. You'll have to use product rule, which is going to be a topic for next module, but that's not what you need to do. So we have to do something different, and this is what we're going to do. Break off all the parentheses, then we're going to get 2 minus 3t minus 2t squared if you distribute around 1, and then plus 2t minus 3t squared minus 2t cubed if I distribute around t. I hope I didn't make any algebra mistake here. And then what do you get? Let's see, this is highest order, let's keep it. Negative 2t cubed, and then negative 3, negative 5t squared, and then minus t plus 2. Let's see, is this right? Okay, that's right. Alright, I successfully broke everything. So let's take the derivative now. Here, let's apply the power rule, multiply by power, and then subtract 1 from the power. Next, again the power rule, multiply by power and subtract 1 from the power. 1 power, so I don't have to write it. And the first power multiply, so I need 1, and then 0 power. This is constant, so that's gone, and that is the derivative function. Let's align the equalities here. Please note that up to here it's just simplification. This is all about f of t, and f prime of t is the next step, and we use the power rule all at the same time. This is the best way to cut down unnecessary mistakes. don't use the power rule in several different steps. You may miss something or you may apply it twice. Let's open up this answer key and let's see, is that the same as what we have? Oh yeah, that's the same. Alright, I don't need duplicate answer key, so let me remove it. Next problem, how about this one? Again, the same deal. If we expand it out, then you'll be able to apply those power rule one at a time. This is complete square, so you can FOIL it. Okay, let's expand it. First, we have 4x to the 6th power. Outside, 6x to the 5th power. This times that we did. And then outside, this times that we did. And then inside, 6x to the 5th power. And then last, this one times that one. 9x to the, let's see, is that 4th power? Okay, let's rewrite it. 4x to the 6th power plus 12x to the 5th power plus 9x to the 4th power. That is the expansion, and I didn't take any of the derivative yet. I didn't use the power rule. This is just a simplification of the original problem. As for the derivative computation, here we go. Let's apply the power rule here. Multiply by the power and subtract from the power. Next, multiply the power. 6 times 12 is, and subtract from the power. And multiply the power and subtract from the power, and that's the derivative function. Is that what we have over here? Oh, excuse me. This is right, and then what I typed in is wrong. Here I just made a mistake. When I'm combining, I ended up mistyping and then getting the 6th power. Should have been 5th power. Because of that, I made a second mistake. Multiplying, we should have get 60 there. Oh, never mind. I don't need duplicate answer keys. In particular, the second one was wrong. Let's go back to this. Break up all those parentheses. This time you can use complete square formula. Whatever it is, we get this simplification, and then we apply the power rule. Multiply the power, subtract 1 from the power. Multiply the power, subtract 1 from the power. Do the same thing and we get that. That is the derivative computation. Okay, how about something like this? Again, the last thing you should be doing is taking the derivative of numerator and taking the derivative of denominator separately. It's exactly the same mistake as doing this and that separately. It doesn't work like that. This is how I would do. Separate the numerator. This is going to be my first step. Separate the numerator. If you have something added in denominator, you can't do it, but in the numerator you can always separate. Next, simplify. 2 over 2 simplify into, let's see, x squared. And this one, 3/2 x to the which power? First power. And then the next one, we have 1/2. And then we have 2x to the 2x to the negative first power. Okay. Now take the derivative. Derivative of this is 2x to the subtract 1 from the power, first power. I don't need that. And the derivative of this, negative 3/2 x to the 0 power, so I don't need it. Derivative of constant, so that's 0. I don't really need it, but I wrote it anyway. And finally, multiply, we get plus 2x to the negative second power, and that is the derivative function. If you remove this plus 0, that's fine. Well, I decided to keep everything just for justification, but if you remove it, simplify, that's okay. That is my suggestion. And that's basically this method. Now we have sufficient time for the second method, so let's talk about that one too. Another way to do that is to flipping up the denominator and change this division into multiplication. What am I talking about? This 2 is in denominator, so we have to have 1/2. Now this x, we flip it up so that x to the negative 1/2 power. That's how you can flip denominator to numerator, by taking the negative power. Now once we have this multiplication, now we can distribute this thing to each term, and we get this kind of simplification, which by the way is identical to the previous simplification. The second line from the previous method and the second line of the second method are the same. Consequently, the derivatives are the same as well. Not perfectly aligned. Okay, that's better. So separating the numerator, that's basically what I usually do, and also our textbook out there. And then simplify, and then take the derivative term by term, standard method. Or you could flip off denominator and change the division into multiplication, distribute around, and then take the derivative. This is also legitimate. Which method do you prefer? Choose one and stick to it. Me, I usually do it this way. Solution 1. Sufficient time. I don't know whether this is really sufficient time, but let's do it anyway. Okay, how about this problem? We have some radical expressions here, but usually it's a good idea to change all the radical into power form before doing any kind of problem. So instead of x times square root of x, I change it into 3/2 power. Instead of square root, I change it into 1/2 power. Okay, and then let's simplify. And I usually do it this way. Separate the numerator. Okay, these three terms now separated into 3. And then simplify each fraction. The number part here is 1/2. and x to the what power? Second power up there, 1/2 power. So subtracting one from the other, I'm gonna get 3/2 power. Next, number part is 1/2. X to the which power? Negative 1/2 power. 0 minus 1/2. I think I forgot factor of 4. Sorry about that. Okay, 4 was there before. So 2 x to the which power? 3/2 minus 1/2. That's 1 power, isn't it? First power, so you don't have to write first power. Next, let's find out the derivative. How about this one? 1/2, which was there before, and multiply by the power, and then subtracting 1 from the power. That took care of the first line. Next, 1/2 was there before, multiply by the power, negative 1/2, and subtract 1 from the power. Finally, this derivative of 2x, that's just 2, and there goes the derivative computation. You can simplify, but I'd rather stop here. What did I do here? Separated the numerator, alright. Got the same simplification as this, and then got the derivative, but here I did the simplification. That's the only difference. Okay, let me remove this. There goes a solution. What if you prefer the second solution? You can flip up the denominator. Let's see, can I squeeze everything in? Let's go back to 100%. Okay. Instead of separating the denominator, instead of separating the numerator, I flip the denominator. This 2 does not flip up. It stays at 1/2, and an x part becomes negative power, and then we just distribute all those. After all those multiplication, we get the same simplification as before, and take this power rule, we get the same answer as before. Please do appropriate practice on these kind of problems, and of course many more. One thing you really have to be careful here is not getting exhausted during those simplification process. Please keep your mind that the derivative part is yet to be done whenever you're doing this simplification. If you just get exhausted and stop here, or mix up the derivative computation, well, that's how a lot of students make mistakes.